Lake Pepin is a floodplain lake located on the Mississippi River, 80 kilometers south of the Twin Cities, and it has two historical water quality concerns. It's infilling at a rate 10 times its historical level, and it has algae blooms, which are the result of high levels of phosphorus in the water. We know from previous research that a lot of the sediment that's infilling Lake Pepin is coming from the Blue Earth County riverbanks. And we also know from research that suspended sediments has the ability to transport nutrients like phosphorus. That leads to my research question, whether the bank materials are inherently a significant source of phosphorus to the Minnesota River and to Lake Pepin, and whether the bank materials have a capacity to absorb phosphorus from the river waters, carry it downstream, and be a source of phosphorus in Lake Pepin. We do know that the phosphorus levels that we see today are the result of human influences. Sewage treatment plants, phosphate fertilizers used in both rural and urban settings, and land application of waste and manure, and phosphate in detergents. This research takes all of these aspects into account and works to find a unique way to manage this environment. We know that the bank materials have a high inherent total phosphorus concentration, but they also have a low Bray and Olsen P phosphorus levels, which means that the phosphorus is tied up in forms not easily accessible for plants and microbes. But based upon our tests, we know that they have the high capacity for absorbing phosphorus, and then they hang on to it or they retain it, which means they fall into the river water and they grab any phosphorus that's in the water, hold on to it, and transport it downstream, acting as a sink and a carrier downstream. If it's above 0.1 or 0.15 milligrams of phosphorus per liter of river water, they'll grab onto the phosphorus in the water, absorb it, carry it downstream, and when they settle in Lake Pepin, they can act as a source of phosphorus based upon environmental conditions. In this regard, I like to use the metaphor of a sponge. The sponge will absorb the phosphorus and it will carry it downstream, acting as a sink and a carrier. And then when it reaches Lake Pepin, based upon environmental conditions such as oxygen levels, pH, the level of the pollutant in the system already, it can then act as a sink and release the phosphorus it's holding. This thesis resolved a lot of questions, but also brought a lot of questions up, which all good science should do. The key to this whole situation is in stabilizing the riverbanks and keeping the soluble phosphorus levels in the rivers below the sediment EPC 0 point. This research is needed because it will give a clearer picture on how total suspended solids are behaving during river transportation and how it affects phosphorus levels.